Yeah, are you your speakers?
Yeah.
All right. Well, good evening, everybody. Welcome to the December 8th, 2023 Rocky Mountain Creation Fellowship meeting. We are live on YouTube from Littleton Baptist Church in Littleton, Colorado. And just for your information, we meet the second Friday of every month, year-round, at 7 p.m. So you're welcome to come to any meeting, always free of charge. And so with that, let's have an opening prayer. Bob, would you like to come up and deliver a prayer?
Happy to. Lord God, Heavenly Father, we give you thanks that we can gather in this place tonight to hear about your creation and how you've made it and how we're served by it. And we pray that you would be with our speaker tonight, Dr. Homan, as he gives his information. Be with us as we hear it so that we can absorb and learn. And Lord Jesus, we pray that everything we do tonight will glorify your name. And it's in your holy name, Lord Jesus, that we pray. Amen.
Thank you. Okay, the scripture reading for tonight is 2 Peter 1, verse 16. For we have not followed cunningly devised fables, when we made known unto you the power and coming of our Lord Jesus Christ, but were eyewitnesses of his majesty. So the creation message, everybody that wrote in the Bible, they were eyewitnesses. All the scriptures are testimony of eyewitnesses. And so that's something to keep in mind. So with that, let us move on to our speaker for tonight. Dr. Homan is a former meteorologist in the Air Force Academy and a retired director of meteorology at the United States Air Force Academy. He was drawn to the study of God's creation at an early age and is an avid outdoorsman, runner, hiker, and skier. You can usually find him playing in the snow, studying snowpack patterns, somewhere on a mountain. He is a regular speaker on the topic of climate change in both secular and church forums. Dr. Homan served as a squadron commander and advisor to the Iraqi Air Force and worked on several international research initiatives during his career in the Air Force. He currently works for the Officers Christian Fellowship as their field staff representative to the Air Force Academy. And with that, let us welcome Dr. Paul Homan.
All right, good evening. Thanks everyone for coming out, braving a cold night. Real quick before we jump into our topic tonight, Rob was kind enough to mention my wife Janae is here with us, my son Matthew is handing the handouts in the back, and my daughter Sarah. But we currently work for a ministry called Officers Christian Fellowship, which is a ministry to the military worldwide. We just happen to be the staff here in your backyard to the Air Force Academy. My wife and I met in a Bible study in Officers Christian Fellowship about 24 years ago now. Plug that in real quick. Here's what we do. We minister to those cadets who are college students in a very unique place. Having Bible studies throughout the week, having them over our house for dinner and things like that. As a quick plug, there we are down in, we live in Monument on the tippy top, highest point on I-25, between here and Colorado Springs. I will be speaking for a week at one of Officers Christian Fellowship's summer programs out at White Sulphur Springs in Pennsylvania. So if you know anyone who's out there and you like what you hear tonight, I'll be talking on this topic and other topics having to do with science and the Bible. So that's in southern Pennsylvania, 8 to 15 June 2024. I'm not speaking there this year, but this is how I met Rob. I met Rob actually out at Spring Canyon. Officers Christian Fellowship also has a retreat center and conference center here in Colorado. It's out behind Mount Princeton, outside of Buena Vista. So that's what we are doing these days. But tonight we're going to talk about climate change. And that's a pretty big topic to try to cover here in the next 55 minutes and then move on to some questions. But really, if you're going to hear a theme tonight, you're going to hear a theme of what has a bigger impact on the climate? Nature, natural causes, or man? And I know you hear in the media that man is causing all kinds of issues and problems, a lot of alarmism, climate catastrophe. Well, I'm going to give you data tonight. I'm going to give you resources. I'm going to give you things you can look up and check for yourself. I'm a former college professor. We are not on lesson 36, right? So I'm going to try to slow things down and explain a few things. But if there's something that you're going, hey, I just don't get, can you repeat that? Stop me as we go. So we're going to look real quick at the Earth's energy balance, which will lead into an overview of climate change theory and the role of greenhouse gases. And we're going to actually start with a biblical earth-keeping ethic versus modern environmentalism. And then we're going to start looking at some of these data sets, temperature data sets, and others, including things like tornadoes, hurricanes, wildfires, and so forth. So, how did I get involved with this? This is one of those slides I could spend an hour on all by itself. But I was a commander down at Eglin Air Force Base. What were the years? About 2013 to 2018. And at the time, President Obama declared climate change as the #1 threat to U.S. national security in his national security strategy. So a slew of documents from DoD started coming across my desk. And just to summarize, it was a whole lot of actually fraud, waste, and abuse of your taxpayer dollars. Here's the original draft of what was called the ICE map, the Installation Complex Management Action Program, Action Plan. It was so thorough, it said Eglin Air Force Base, and I can prove it to you, it's still here, I have the hard copy. It said it was in the Pacific Ocean. Yeah. Okay? So there's just a lot of sloppy work. One of these things that came across my desk by the Union of Concerned Scientists, they published a paper, it didn't even have a methodology chapter. So they were hiding their methods in what they were publishing. It just really concerned me that we were in such a poor state of science, especially within DoD, and that's how I got drug into this. So my wife, one day, she asked me, well, where's Jesus in this? Where is Jesus in this pursuit? Because I'm staying up late, reading everything I can, starting to do these types of presentations. And then I ran across this website, and I ran across this article on this website. This is their article, and it's entitled, Defending Science Education, Climate as a Second Front for Biologists. So what's the first front for a biologist? Evolution, right? So in this article they published on this webpage, they basically said evolution is clearly ensconced in K through 12 education, public education. Climate change must be as well, because if the students start to critically think about climate change, they might start to critically think about evolution. So we have to control the narrative. Don't think, just do what we say. Science is settled, and that really disturbed me. This organization is called the National Center for Science Education, and if you notice, they added the climate change to their title, Defending the Teaching of Evolution and Climate Science. This was what the webpage looked like, almost 10 years ago now. They've updated it. They want communities to resist threats to accurate and effective science education. And if you note, they actually, in this sub-slide on their website, they actually put climate change emphasis before evolution. And so really what we're going to be talking about tonight is a pursuit of truth. And sometimes when you speak out for truth, this is one of those scientists. His name is Dr. John Christie. He's actually a Christian. He used to be a missionary in Africa. And he is the Alabama state climatologist. In fact, he was the president of all state climatologists, has testified before Congress many times. And 15 minutes after Earth Day parade in Huntsville, Alabama, his office was targeted with the shooting just a handful of years ago. So sometimes when you speak up for truth, some forces don't like that. So why should we care as Christians about this topic? I think it honors God when we hold to a biblical worldview that is accurate and consistent with the Bible. And in various scriptures that I would love to go through tonight and spend the whole time, but we want to get to some of the science as well. Colossians 2:8 says, "See to it that no one takes you captive by philosophy and empty deceit." Certainly arguments about who Christ is and God and the Creator. But you'll see that actually, as I'll set up here, this whole argument is actually an attack on our Creator. In 2 Corinthians 10:5, it says, "We destroy arguments and every lofty opinion raised against the knowledge of God." That phrase there, the knowledge of God, is going to be very key as I go forward. So, if we were going to spend time and we jumped into Genesis, what is the biblical worldview of the environment, God's creation, and man's role in it? Well, we see this mostly in the early chapters of Genesis. Genesis chapter 2, verses 7 and 15 show us that the creation was an intentional design by God. And after the first day, he said it was good. And the second day, good. And by the time he gets to the sixth day and he puts man on creation, what does he say? He says it was very good. So he tells Adam and Eve to go out into the garden, to work it, to have it bring forth fruit, to guard and protect it. Yes, we have a responsibility to not make the water dirty and not make the air dirty and make it so that life can flourish here on the planet. But that doesn't mean not to use God's natural resources. And then God gives us dominion over the planet and tells us to use it to bring glory to himself. So let's contrast that with the modern environmental movement. This is not true of every person out there. I would consider myself an environmentalist. I grew up, I think my mom's out there watching. Hi, Mom. I grew up on the Potomac River in the 1980s, about 20 miles south of Washington, D.C., and that river was polluted and dead. I saw it. I saw these things firsthand. They did a lot of things to clean it up, and now the river's thriving again. If you turn on ESPN2, you can go right out in front of my parents' house and see the bass boats going by on all the bass fishing tournaments. They have done steps to clean it up. So man can cause impacts to God's creation in a negative way. But the number one assumption of most modern environmentalists, especially secular humanists that you see in a lot of our media, a lot of our politicians, and certainly in a lot of our university, their worldview starts with that there is no God. They deny the knowledge of God. And then they say that the earth is very fragile. It's a big cosmic accident. And therefore, because it happened by random chance, it is fragile and needs to be protected at all costs. And then they pit humans as the enemy of nature. You're seeing more and more wilderness areas being created that man is not even allowed to enter. As if when man walks through the forest or walks through a field and we step on, bend a blade of grass, as if we've done something wrong. Man is not an enemy of nature. What this happens to lead us to, which is a big fancy word called pantheism. Here in Colorado, we have a colloquial term for that. That was Matthew's word of the week. We were saying colloquial, Matt, remember? What do we call it here in Colorado? Tree huggers. Right? This leads to the worship of the creation rather than the creator. When I see the mountains out there, I'm not worshiping the mountains. They're beautiful, but we're worshiping the creator that made those mountains. In fact, it talks about this in Romans 1:25. It says they changed the truth of God for a lie and worshipped and served created things rather than the creator. And I think it's quite interesting that Proverbs 1:7 says, the fear of the Lord is the beginning of knowledge, not the denial of the Lord. But those fools, they will despise wisdom and instruction. So very quickly, we touched on a few verses there, but the idea of nature untouched by humans, or humans not interacting with nature, is just not a biblical idea. We don't see that at all. So a quick couple of definitions as we move more into the science piece. Everyone's heard of the UN. The UN has a body called the Intergovernmental Panel on Climate Change, or IPCC. They were established many years ago, and they put out these assessment reports every handful of years. A lot of the things that I'm going to be quoting from are going to be from their assessment report number 5, which was released in 2014. They did release one this summer. I haven't had a chance to go through every little detail of it, but I haven't seen anything that's too dramatically different yet. So I'm a scientist, and we're going to do a scientific experiment tonight. We're going to walk through the scientific method. We're going to test a hypothesis, and we're going to look at data, and you can come to your own conclusion about whether or not the data I present supports the hypothesis put out by Science Magazine in 2010. Basically, what Science Magazine said in 2010 is that natural causes have always caused the climate to change, and that's a true statement. But now, human-induced or anthropogenic causes are overwhelming nature, and that the warming planet is speeding up at unprecedented in modern times, and we're going to see Chicken Little, the sky is falling, more hurricanes, more wildfires, more tornadoes, more droughts, more floods, more. And, well, we'll look at the data tonight and see if their hypothesis from 2010 is correct or not. So, big disclaimer, I am not a climatologist. All of my degrees are in meteorology. Meteorology is just the study of the atmosphere and everything in it. I was a weather guy in the Air Force and a professor at the Air Force Academy for over 20 years. But climate is just the sum or the average or some amount of putting weather together over time, and that becomes climate. So I think I have a little bit of a leg to stand on to talk a little bit about climate. Weather is what's happening tonight. Climate is what we might expect to happen 10 years from tonight, or what the average is for tonight. I've already used the word anthropogenic, just meaning man-caused. Often when you hear the term global warming in our media, it's assumed that it's man-caused. I'm not going to do that tonight, so I'm going to try to differentiate between natural causes of warming and man-caused of warming. And of course, the term global warming got out of vogue, and I'll show you why, because it wasn't warming any longer for about 15 years. And so they changed it to climate change. Now anything can be a catastrophe. If it warms, catastrophe. If it cools, catastrophe. If it rains too much, catastrophe. If it rains too little, catastrophe. Climate crisis, etc. So now we're set up. You all ready to do just a little bit of science tonight? All right, so the first thing we're going to talk about, this is a very simple graphic about Earth's energy balance. We have energy that comes into the Earth, primarily from the sun, and then we have energy that escapes the Earth. And if in equals out, the temperature is constant. We're in equilibrium. So in order for the globe to change in temperature, heat up or cool down, something has to change in this simple model. So for instance, if we get a little less sun, the N would be smaller, and I show that here in the arrow getting a little shorter. Now we're out of balance. If there's less coming in than going out, what's going to happen to the planet? It has to cool. The temperature has to go down. We could reverse this scenario. We could have a little less going out for some reason, and this is where the greenhouse effect and things go in. So if we have more coming in than going out, we're going to warm up. See how this works? It's not that hard. But let's make it just a little bit more complicated. Again, the N is almost exclusively sunlight, so that doesn't get any more complicated. But there's really only two ways energy can get out of our planet. Some of the sunlight can be reflected, so that's the yellow arrow there. It can be reflected off clouds. It can be reflected off aerosols or dust particles in our atmosphere. It can be reflected off of snow or glaciers or bodies of water. First term of the night, we need to become pretty familiar with, infrared radiation. Infrared is the energy that bodies roughly the temperature of you emit most of. You are emitting infrared energy. If we turned off the lights, would you be glowing visibly, right? Like the sun. We do not emit very much. Everything emits a little bit of everything. But our maximum, we do not emit visible light like the sun does. If we put on infrared goggles, like many in the military do, forward-looking infrared radars and things like that, we can see infrared. So if we put on our infrared goggles and turn off the lights, every single one of you would be glowing hot. And so is our planet. It's always emitting infrared energy. That is how energy gets out of our planet. So we could reflect a little less sunlight. So now the out is smaller, and we would warm up. Or have a little less snow on the ground, or less clouds to reflect. Or we could reflect a little bit more, and that would cause us to cool down. And then this is where we're going to spend most of our time talking tonight. The amount of infrared energy that gets emitted back out into space, that can change. So if the amount of infrared energy going out were to get a little less, that means we're keeping more energy in, we would warm up. And I want to introduce a term, most of you have heard this before, but this is called the greenhouse effect. This graph looks a little bit more complicated, but if you look at the out arrows, those out arrows are really still just the same two out arrows. It is reflected sunlight, either off the Earth's surface or the atmosphere, or over there in the far right-hand corner, energy that is emitted from the Earth is infrared. We have a particular set of gases, which we're going to explore tonight, that do not absorb sunlight. So as the sun comes in, there are various gases in our atmosphere. The sunlight is not absorbed. It passes right through. It might scatter, giving us blue sky or red sunsets, but the sunlight hits the ground. The ground absorbs it. It re-emits it just like you do. Right? When you go out and get your suntan, right? You absorb that solar radiation and then you emit the infrared and it tries to escape to space. But there's a particular set of gases that do not absorb sunlight but do absorb infrared radiation. And these are called greenhouse gases. So before we get into the greenhouse gases, I took this graph from Dr. Judith Curry, who formerly taught at Georgia Tech. And what this graph shows is the net flux or energy at the top of the atmosphere as measured by NASA satellites. This is a graph of those arrows the sum of those arrows. So that the net flux is just the incoming solar, the red arrow we were looking at. Let me go back, the red arrow, minus the reflected solar, the yellow arrow we were talking about, and also minus the emitted infrared, the outgoing long wave. And what you can see is that over the last, this is since 2000, the last 2 decades, we have seen the net flux at the top of the atmosphere going up, which would correspond with we're getting warmer. But we can dig into those other terms and look at why are we getting warmer. And that's what the next graph does. So a little bit complicated here. But the colors correspond with exactly what we've been talking about. So let's first look at the red, which is the incoming solar. The sun goes through roughly 7-year cycles of more energy coming from the sun and then less and more than less. And you can see that. More, less. And what are we in the last handful of years? More, which makes sense. We are at solar maximum. The sun is actually incredibly active. We've been seeing geomagnetic storms in the aurora all the way down here to Colorado recently, meaning we have a very active sun. So superimposed over that, you can see the yellow, which is the reflected sunlight. Does it look constant, or does it look like it's always changing? it looks like it's always changing. We have what we call positive anomalies for a period of time. And I want to draw our attention to 2015 because the reflected solar was a positive anomaly. In 2015, it flipped and became a negative anomaly. Negative anomaly meaning we are reflecting less solar for some reason. So less snow, less glaciers, less stuff up in the atmosphere. It doesn't tell you what it is, it just says we are reflecting less solar as measured by the satellites. But notice the blue, which is that outgoing infrared, is it constant? Or is it always in flux and changing? It's always changing as well, and it was pretty much negative, and in 2015 it flipped and is higher. So, try to make some sense of this graph. If we are emitting less infrared, emitting more infrared, that means it's not being absorbed. What are we being told that's absorbing all this infrared at ever increasing rates? Greenhouse gases, in particular, a couple we'll talk about in a minute. So according to the simple model that I set up, yes sir?
Infrared is the blue line?
Infrared is the blue line, just like the previous graph. So we were absorbing more, and now we're absorbing less or emitting more to space, okay? While reflecting less to space, while having an active sun, leading to a net of more energy staying in our system. I know that's a bit complicated, but let me illustrate it with something that happened 2 years ago, which kind of show how big the natural forcings are here in our atmosphere. All the squiggles are the instantaneous or data, and then the darker bolded lines are the average. So if you look just this last summer, right at the end, do you see some massive changes really, really fast just last summer? And if you were paying attention to the news, it was an incredibly active summer in terms of weather. And of course, the climate crowd all said, oh, the sky is falling, the sky is falling, the sky is falling. I think I can explain why it changed so fast. So let's look at what happened. All of a sudden, last summer, looking at the blue line, we started emitting a ton less infrared to space. That means something kicked in that started absorbing more energy, keeping us and helping us warm. And then all of a sudden, we started, whoops, giving away here. We started starting to reflect way more all of a sudden, for some reason. Anyone have any idea what that might have been? Sir, do you know? Water vapor from what? Anyone hear the Hunga Tonga volcano? Okay, over I think in roughly Indonesia. It erupted under the ocean. And most of the time, and I'll show you in future data, when volcanoes erupt, they put ash up into the atmosphere, and that ash and the soot and the aerosols get trapped in the stratosphere, and they block sunlight. So usually volcanoes cause cooling on the planet, but because this one, none of the ash made it in the atmosphere because it was all down in the ocean, it shot, you ready for this? It increased the atmospheric water vapor by 10%. One volcano, as said by NASA at the JPL, Joint Propulsion Lab, one volcano increased the amount of water vapor in our atmosphere by 10%. And then you can see the very quick, dramatic changes. So I know it took me a while to digest what's going on in this graph, and I know it might seem complicated at first look, but if you were to ask me where the man-made contributions are on this graph, I can't point to it. But I can point to you in several places, like I have with the Hunga Tonga volcano, the natural forcings, the sun, the volcanoes, and other things happen on such dramatic scales that if there is a man-made contribution, I can't see it because it's so small, because of the natural forcings. And that's going to be a theme as we go forward tonight. So really interesting paper done by NASA looking at the Hunga Tonga volcano. So we've touched on these. The main gases in the atmosphere are nitrogen and oxygen. Not going to talk about them tonight. They're real important. They're important for us to breathe, but they're not greenhouse gases. They do not absorb this infrared that we're talking about. The number one, this is taken from a textbook that I've used when I've taught. This is not up for debate or dispute. These are facts. You can pull out any meteorology textbook. The number one greenhouse gas that absorbs that infrared is water vapor. Water vapor is a variable gas in our atmosphere. They talk about water vapor on the news every single night. What word do they use? Humidity, right? You all know this. Humidity varies with time and location, and daytime to nighttime, and desert to tropics. So it's very hard to model and very hard to track. The next one, let me say water vapor on average is about 2% of our atmosphere. In the tropics, it can get up to about 9 or even 10% or 1/10 of our atmosphere. Okay? Versus carbon dioxide, which you hear in the news all the time. This textbook I pulled it from is a little bit old. I think they're up to the 12th edition. We're over 400 parts per million. It's about 420 if we were going to go out there and measure tonight. And the whole debate about climate change is when we started burning fossil fuels about 1880, 1860, somewhere in there, with the invention of the combustion engine, we were at about 300 parts per million. So man, from burning fossil fuels, has increased carbon dioxide in our atmosphere from 300 parts per million to roughly 420 parts per million. The real question we're looking at is, has that made such a change that we are impacting the climate to any significant amount? And then we get into methane and others. Methane about 1.7 parts per million. And so I actually couldn't find this graph online. I had to make it myself because of the misinformation campaigns out there. But strictly by volume of the atmosphere, if I just take the average, 2% of our atmosphere, that would be 20,000 parts per million, if we want to put it on the same scale that we measure CO2. Water vapor, 20,000 parts per million. Again, CO2 about 400 parts per million. And then you get into methane, nitrous oxide, others, 1.7. So roughly 98% of the greenhouse effect by volume, just by counting molecules, is water vapor. CO2 is about 2%, and you put all the others together, I can't even get it to round up to 0.5%. It's essentially 0%. We talked about this just a little bit. We're going to get back to how the media portrays. Is this microphone slowly dying? I don't know.
I don't know what's going on. Let's try it.
Let's switch microphones real quick. Thanks, Rob. So in order to understand this next graph, you have to have at least a small feel for the electromagnetic spectrum. You have things like gamma rays, X-rays, really high energy, really short wavelength. Then we move into ultraviolet. Then we have visible light, which we all are familiar with. And then as we move to lower energy, longer wavelengths, we get into the infrared that we've been talking about. So what this graph shows the energy output by the sun, the spectrum of where the sun puts out its energy. You can see that that's primarily in the visible range, sunlight, right? This is what your eye sees. And what this shows is what gases in the atmosphere absorb or scatter that wavelength of energy. So, for example, sunlight, visible, mostly passes through our atmosphere without being absorbed. We know that, otherwise we wouldn't get sunlight. Something the sun does emit some of, which is harmful to us, UV, right? That's why we put on the sunscreen. So if you look, the sun does emit some UV, and then it is absorbed part of the time. And what gas absorbs it? Ozone. See how that works? So that's the sun. So let's look at the greenhouse effect and look at what the Earth emission is doing. So here are the wavelengths that the Earth emits based off our temperature of the planet. And here's the total. And what do you notice about what gas is responsible for absorbing more than anything else? It's water vapor. So as we look over here on the right, not only is there more water vapor, I've already demonstrated that, it has the highest radiative forcings across the broad spectrum of infrared. So when you look at CO2, CO2 only absorbs infrared at these two wavelengths. There's one about 15 microns, and then one over here, I think it's about 6. So let's look at the one in the middle. This is the one that would be concerning if water vapor didn't already absorb it about half the time. And if you look over here to the one on the left part of the spectrum where CO2 absorbs, water vapor does not absorb there, but does the Earth emit much there? The Earth doesn't emit hardly anything there at all. And Fred and I were talking on the Real Science Radio last week. Methane, remember 1.7 parts per million? Look where it emits. It only emits and absorbs in one particular wavelength. And what already absorbs there 100% of the time? Water vapor. In other words, if energy trying to escape to space is already 100% of the time absorbed by water vapor, does it make much of a difference if we keep increasing methane if it's already absorbed 100% of the time? In other words, does a photon of energy care whether it's absorbed by water vapor first or methane first? It doesn't change the net effect. And if the methane's not there to absorb it, water vapor will absorb it a nanosecond later. So what I've highlighted in yellow are the only places in terms of carbon dioxide where man could play on the fringes a little bit by adding more carbon dioxide. So I hope to demonstrate to you tonight that by far water vapor is the most important greenhouse gas because we have more of it, it's hard to model, and 3, it absorbs across a much broader spectrum than any of the others. But which ones are they trying to regulate and pass laws over? In fact, in the 2014 IPCC report that I referenced, the initial summary mentions CO2 119 times. Yet it only mentions water vapor 0 times. Why is that? Well, let's get into that. So this graph might look complicated at first, but this is the various absorption bands on the top just for CO2 and on the bottom for methane, those ugly and dirty greenhouse gases that we have to regulate. The green curve would be if we had none of it, 0. The black curve is where we're roughly at today. And then the red curve, if you can see it, is if we doubled that gas. So CO2, there's that big absorption band that we talked about. It's absorbing about that much of the infrared trying to go out, and if we doubled CO2, do you see much change? This was done by Dr. Will Happer at Princeton, and you go down to methane, you do the same thing, 0, current concentrations, doubling concentrations, and you can barely see any difference. Here's the analogy I have for you that should help you understand why the change for doubling something doesn't change much. When it's chilly here in Colorado, like tonight when you go home, you're going to put a blanket on you, right? And that's going to slow down, change that equilibrium of that in versus out, right? You're slowing down what can go out. And that one blanket will warm you up some. And if you're still cold, you can put a second blanket on. But are you going to warm to some infinite temperature just because you put a blanket on? You're going to have runaway warming if you put a 4th or a 5th. And by the time you pile 20 on top of you, will you feel any net change very much at all for that 21st blanket or that 22nd? It doesn't make any sense, right? Well, that's what you're seeing here in the atmosphere as well. So increasing amounts of greenhouse gas have ever decreasing effects as you get to higher concentrations. Does that make sense? And I need to say this, if we had no greenhouse gases in our atmosphere, we would freeze. The planet would be too cold for life. So that's an important thing. God gave us greenhouse gases so that our planet is habitable. So that's pretty interesting. But this is what you see in the media. This is ABC News. This graph shows the distribution of greenhouse gases in Earth's atmosphere. Carbon dioxide is clearly the majority. I have a name for that. It's fake news. It's not true. I have a Weather Underground app on my phone. You might as well. If you go to Weather Underground's page and they try to explain this greenhouse effect, this is the graphic they give you. Greenhouse effect is CO2 and other. Like the most abundant? Like the one that has the most, just most radiatively active, absorbs the biggest spectrum. So that's Weather Underground. Here's your tax dollars at work. This is the EPA. Overview of greenhouse gases. No mention of water vapor again. They get a little cute and they say, well, this is overview, not of the atmosphere, but overview of man-made emissions. Do you see that? Overview of emissions. Again, no mention of water vapor. Well, what comes out of your tailpipe? CO2 and water vapor. A byproduct of combustion is CO2 and water vapor. On a cold night like tonight, you're going to go out and you're going to see the contrail coming out of the condensation happening on a cold night as the water vapor comes out of your tailpipe and condenses. By the way, what's the byproduct of, or the emission of respiration? This is a good reminder. CO2, you breathe out CO2, but you also breathe out water vapor. Go outside tonight, breathe out. Can you see your breath? That's water vapor condensing back into water. And we all know we don't have very much water vapor here in Colorado. That's why I got to take a swig. Because it's a dry climate. So why are they, sir, do you have a question?
Yeah, so you're saying they simply pull water vapor out of the denominator to make the whole thing look
Correct.
dangerous.
So the only way you can get that graph is to take water vapor out. If you put water vapor in, it's what I showed on the slide several ago, it looks like this. So that whole graph is zooming in on just that 2%, but claiming it somehow represents the whole. Does that make sense? So we let Weather Underground get away with it. We let the EPA get away with it. Thankfully, the meteorologists are the smart folks. This is the National Weather Service, or NOAA, and this is their page on greenhouse gases, and they say water vapor is the most abundant greenhouse gas in the atmosphere. Okay? So maybe the EPA should call over to across Washington, D.C. and say, hey, weather guys, can you set us straight? But I don't agree with everything they say. I do agree with it is still fairly poorly measured and understood, yet science is settled and we know everything that's going to happen, but we don't understand it. But what we're going to spend a little bit of time on tonight is the reason why, sir, they say they can ignore water vapor is water vapor doesn't force the climate, it's a result of the climate change or a feedback. I completely disagree with that, and I'll explain why. One, water vapor forces the weather. I have not run into one meteorologist like myself that says, in order to determine how much it's going to snow tonight, where we have to deal with the hydrological cycle of phase changes of water, gas, solid, ice, water vapor, all that, liquid, we get to ignore water to figure out how much it's going to snow tonight? No. Water vapor, humidity, ice, the hydrological cycle is what drives weather. And if climate is the sum of weather or the average of weather with time, how can the thing that drives weather not be a forcing for climate? That's the simple argument I make, and I'll show you data to support that as well. And that's what they're saying in that other red box, is that, climate is not forced by water vapor, so we can ignore it and only look at CO2 and methane. So, Dr. Christie, the guy who was shot at, and one of his PhD students, Norris, back in 2006, Let me explain this graph. A lot of times when you're looking at a graph of mean temperature, and it's going up, you go, okay, mean temperature, what is mean temperature? And so I went back and I called Dr. Christie and I said, hey, how'd you compute this? And he goes, it's very simple. It's just the daily maximum temperature plus the daily minimum temperature divided by 2, mean temperature. Okay, so what they did is this for a data set in the Central Valley of California. What you see here is data taken from 3 locations. In the valley floor, in the Central Valley of California in red, the adjacent foothills, we understand that here in Colorado, up in the foothills a little higher, and then up in the high Sierra. Okay, that's the green. So the green you would expect to be cooler because it's up much higher in elevation. And so actually let's look at the bottom graph. That's just the graph of the maximum temperature. And you can see there are warm years, there are cold years, but notice that the valley floor and the adjacent foothills basically stay in lockstep for the maximum temperature. But if I go look at the minimum, what do you see happening right about 1970? Instead of staying in lockstep, all of a sudden the valley starts to warm and the foothills stay cooler. What could cause that? I heard it.
Farming.
Farming. And what in particular was farming? Irrigation, which is water, which then evaporates and becomes water vapor. So this is, I'm trying to show you, this is not a natural forcing. This is man-made change. But it's not CO2. It's not methane. It's water vapor that they choose to ignore. And it seems to be forcing a temperature change. So if you only saw a mean temperature going up in the valley, and you were lazy scientifically, you would say, oh, well, that fits climate change theory. We're increasing CO2, and therefore it's getting warmer. CO2 is a well-mixed gas. Does it disappear during the day? Is that why there's no warming? Does it change night to? No, it's the same night, it's the same day, it's the same pretty much everywhere on the planet. It's equally spaced out. So this cannot be CO2, at least on a first order effect of what's causing that warming. Does that make sense? So we could take mean temperature and break it down. So I was at Eglin Air Force Base, so I went ahead and plotted the mean temperature. That's down here on the bottom. And you can see the red line. So if I only gave you the mean temperature, you would go, it's getting warmer at Eglin Air Force Base. I guess we should stop driving our SUVs because CO2 is causing it. But when you look at the max temperature, that line is pretty flat. It's not getting warmer during the day. It's getting warmer at night, at the minimum temperature. At Eglin, I don't think it's farming or irrigation for farming. It's irrigation for something else. Anyone play golf? You go, this is the same, I've done the data out here at DIA. At DIA, it's not water vapor, it's concrete. Palm Springs in the desert in California, just a few more golf courses than 50, 60 years ago. So when you see these graphs of the temperature in Denver is going up, and the temperature in Palm Springs is going up, and the temperature in Florida is going up, we can do very simple things and break it down and show that it's not getting hotter during the day typically, it's just getting warmer at night. Why is it warmer at night? Water vapor. We know this. What happens on one of those really, really cold nights here in Colorado and a cloud moves over? Do we drop down to minus 15 those nights? No. Because in order for that cloud to be there, there has to be water vapor. Anyone ever spent time in the desert? What happens at night? It gets really cold. Why? No water vapor to keep you warm. So I think I'm trying to demonstrate again that water vapor can be a forcing of the climate, and they shouldn't be ignoring it, but they are because they can't regulate it. So let's look at some temperature data sets. How are we doing on time here? All right, yep, we're doing okay. So this is a graph published in Physical Geography, a very reputable, peer-reviewed geological, and this shows the temperatures over roughly the last 1,000 years. 2,000 years. And you can see some ups and you can see some downs. And when I'm teaching this in class, I always ask my students, what possibly caused some of these ups and these downs? And the first answer they go out, they go, carbon dioxide and the burning of fossil fuels. I said, back in 600, 800 AD, 1000? So what you can see in this graph is different periods, the Roman warm period, then some cooling, the medieval warm period. In Europe during the medieval warm period, incredibly prosperous time. It's when all your castles and cathedrals were built in Europe. It was so warm in London that they were able to grow grapes. In fact, if you go to London today, you will find sections of town named after the type of grape they grew there back during this time. It's too cold to grow grapes in London. And then for some reason, it got mighty colder. During the medieval warm period, Vikings moved from Norway and that area over to Iceland into a place they named Greenland because it was so warm it was green. And then they moved down into Canada and all the way down to Newfoundland, and then they died. And one of the reasons they died out in Canada, we think, is because it started getting super cold. This cold period that lasted until about 1700, we call the Little Ice Age. We don't know exactly what caused this, but we suspect it was an abnormally low amount of solar activity. And during that period, Galileo invented this thing called the telescope, and we actually started monitoring the sun, and we do have some data to back that up. Real quick, how do we get this data? This is from proxies. These aren't direct measurements of temperature. They're proxies that measure something that might be related to temperature, like ice cores, or the amount of isotopes in a certain amount of gas, or the amount of pollen that's captured in a certain process. They put all those together and they're able to reconstruct it to give you a rough idea of major changes in temperature. So I've been purposely hiding the last 150 years, and there's the thermometer and satellite record. So I'm not a global warming denier. I am showing you that it is warming over the last 150 years. In fact, it's actually been warming since about 1700. The current warming did not start with the burning of fossil fuels. It started about 150 years before. All those tales of Valley Forge and how bad the winters were during the founding of our country, those are true. It was incredibly cold. Even Thomas Jefferson wrote about it during his lifetime of it getting warmer in Virginia and the snow's not coming down the mountains near as much. So we don't know for sure what caused this warming for 150 years, but your media, your government scientists, most of the folks out there, they're convinced that this warming, which by the way is not any more dramatic than the warming in the previous 100 years, not really all that different than the warming back 1,000 years ago. It's not new and it's not unprecedented unless you tinker with your data and make this graph. This was produced by Dr. Michael Mann before he was a doctor in his master's thesis at Penn State and published in 1999, I believe. And this is what's referred to as the hockey stick. And you can see the long shaft and the short blade, see the hockey stick. And this is what was made famous in Al Gore's movie, The Inconvenient Truth. Do you see a medieval warm period? Do you see a little ice age? This is just the last 1,000 years. This is the same exact data as the one we were just looking at, minus one thing. And by the way, the one on the top was published later, and he took Michael Mann's data, and he said, we know it's warming, we have thermometers, but one piece of proxy data has the sign backwards. It's an inverse relationship, not a direct relationship. It's tree rings. If you only put up tree rings, the method they were using, Michael Mann was using, would say we would be cooling. But we know we're not, we're warming. And so, I think it was Dr. Lindquist, removed the tree rings, and that's the difference you get. So if you have something the wrong sign, when it's warmer, it would make it cooler in your data, and when it's colder, it would make it warmer, and make it nice and flat. And then you can say, because this is the same data, guys, on the far right, you could say this is unprecedented, this is alarming, something major shift has happened. This has been thoroughly discredited, and even the IPCC report doesn't use it anymore, but yet it's the most proliferated chart you will probably see in this debate. Real quick, I plotted these data. Concentration of CO2 is measured in parts per million. Temperature is measured in Celsius. Are those the same units? So how do we plot them on the same scales? So here's what some people do. This is the same data plotted 3 different ways. So this is the temperatures over the last 130, 140 years. This is the CO2 concentration in orange. So if you plotted it this way, you could say, oh, just a small amount of change of CO2 causes very dramatic shifts in temperature. See how you could play with it and do it that way? Or if you wanted the other point of view, you could say, oh, well, you can create all kinds of CO2 and the temperature change is really, really small. Both are just equally as accurate. It's in the interpretation of the data. You can't interpret the data based upon how you graph it. So what do most people do? They plot it like this, where they try to overlay them right over top of each other. So Rob gave me my 10-minute warning, which I asked him to do. We'll provide the slides, but the bottom line is we see periods of a lot of CO2 going up, but we see periods of cooling even when you plot the data like this. This is my favorite data set. This is satellite temperatures that we've had these since, we have about 40 years of data, 45 almost now, from 1979. We see natural forcings like volcanic cooling. Mount Pinatubo erupted in 1991. The earth cooled for a couple of years. We see really strong El Niños. One of the strongest ones ever was 97, 98. And guess what? We're in one of the strongest El Niños ever right now. One of the reasons why we're really warm. I think we peaked 2 months ago in October, and we're going to start seeing us come down because El Niño is going to fade to La Niña, and the sun's going to start producing less, and all that water vapor from Hunga Tonga will finally wash out. If you invite me back a year from tonight, I promise you the global temperature will probably be lower, unless we get another Hunga Tonga or something like that. There's the pause where we didn't warm or change for 15 years when global warming became climate change. I'm not going to necessarily, I'm just going to throw this up real fast. Remember those feedbacks we were talking about? If I have more CO2, I'm going to warm, and I should a little bit. But then if I warm, I evaporate the ocean, so now we have more water vapor. That's why they say water vapor is a response. Now if I'm warmer because there's more water vapor, I get warmer, and I get warmer, and you can have these folks duped into thinking we're going to have a runaway positive feedback. But the problem is we have a lot of negative feedbacks too. Precipitation, clouds, evaporation itself, they all come in balance. And the bottom line is that here is all the UN models showing one particular feedback is all one direction. And when we went and measured it, they have it 100% wrong. So no surprise, as I go forward here, that the models are not getting it right. So these are the models that the UN used in that IPCC report. The red line is the average of 102 showing warming. All of these circles and squares and diamonds are the various data sets I've been showing you, the satellites and the thermometers and the weather balloons. And they do show the warming and the pause and then some warming. But notice that the models are warming at a much faster rate than what the data is showing. Which one's reality? The data, not the models. Direct quote from the IPCC report, climate projections and associated risk assessments for future warming are based on reality. No, they're based on these computer models that aren't getting it right. And they tell us that we know those models don't include all those system feedbacks because it's an incredibly complicated system. Here's that same data in another way. There's the average of all the models. Here's reality. How many models are getting it right? Not too many. Vast majority have a warm bias. If you make up your mind of how you want to design a model, you'll get the answer you want. Out of time, but more data that says the exact same thing, not just warming at the surface, but warming upper parts of the atmosphere. Too much in the models. They don't match reality. So real quick, I promised you we would look at some of the hydrological things like hurricanes. So everyone's been told you've been getting more hurricanes, right? Well, here's the data. It's updated through November 30th of this year. The top line is global hurricanes. Do you see this acceleration of more and more hurricanes? Nope. Maybe we're not having more. Maybe we're having bigger ones though. Well, here's the graph of the bigger ones, the category 3 and 4 and 5, the really destructive ones. We're not having more of them either. In fact, between 2005 and 2017, we had the longest drought of big hurricanes hitting the continental United States. And as soon as we get one, Hurricane Harvey, the sky is falling, they're more, they're bigger. I mean, it's not even close. The average is about 500 days, and we went, I calculated, 4,320 days without a major hurricane hitting the United States. And almost all of you in this room were alive during that time, and they were lying to you the entire time, saying, we're getting more, we're getting more, we're getting more. There weren't any. In fact, this is just another way of looking at the same data. This is the major hurricanes hitting the United States. We are in a definitive downward decline. And everything I'm giving you, here is the data where I'm pulling this from. Okay, tornadoes. We're getting more of them though. Here's a graph that shows more tornadoes. When in fact, we're not getting more tornadoes, we're getting more people to report tornadoes. We developed the Doppler radar, which allows us to see, and we fielded it in 1988. There's 1988, and what happened after we fielded Doppler radar? We detect a lot more tornadoes. So NOAA, the National Weather Service, when they detrend the data for population growth, in fact, we don't think we're getting more tornadoes. It's pretty flat. Or 2018 was the lowest number of major tornadoes in history. So we're not getting more, and we're not getting bigger ones. We're actually getting less. Wildfires here in Colorado. This makes me a little upset. So this is thehill.com reporting that 2020 was a new record for wildfires. If you don't look before 1983. So I went to the website a few years ago, I downloaded the data. Here's the data on the left. Yes, we are in a modest upward trend of wildfire acreage here in the United States. But in order for 2020 to be a record, you need to go from 10 million acres burned to over 50 million acres burned. It was short of the record by a factor of 5. And conveniently, a month after the current administration took office a couple years ago, all the data between 1983 was deleted from the government webpage. If you go to this link today, I went there today, you cannot download the data that I'm showing you tonight. It's been expunged. It's out on the black websites like people like me keep. Percentage of days over 95, less. Droughts. This is for the continental United States. We have big droughts, we have small droughts, up, down, wetter periods, cooler periods. The blue line is the trend line. We actually are slightly down for the amount of drought in the United States, not more. I know you hear California, the West, 2,000-year mega drought. Well, here's the data, and it doesn't show it. In fact, out of their report, which this is their Bible, they say that they have low confidence in the sign of drought trends since the 1950s. The UN, which is primarily cited for the sky's falling, sky's falling, sky's falling. If you go 1,000 pages into the report, they go, whatever the change is in droughts, it's so small we can't detect it. Floods, no evidence that surface water or groundwater drought frequency has changed from the IPCC. Sea level rise. The seas have been rising, I think, since the flood, right? A lot of that ice during the flood got locked up in the poles, And we know that we had land bridges getting down to Australia. We know we had land bridges that connected North America and Asia. That's how the Native Americans got here, and it's been rising slowly ever since. I see no acceleration in sea level rise. It's very linear. There's a paper out on the table out there that I wrote that shows that. Don't have time to talk about glaciers, but you can imagine with that little ice age, the glaciers grew very rapidly and then melted very rapidly well before we started burning a lot of fossil fuels. In fact, just one quick statistic, I calculated a glacier retreated from 1794 to 1912 about half a mile per year. And the supposed accelerating, they're diminishing faster than ever. It's actually only shrinking at 178 feet per year now. So most of the melting of a lot of our glaciers was before CO2 could have played a factor. One piece of new data, this is a paper that was published this summer about Antarctica, and it turns out that the temperature has been going down in Antarctica for 2 or 3 decades. If you see a paper out there that says the sky is falling, Antarctica's warming, you can cherry pick a warm spot and write a paper about it. But do you see more red on that plot or more blue on that plot? So the trend in Antarctica is actually cooling right now, not warming. That you can find thousands of papers out there in the media that say Antarctica is on fire because they only look at one spot instead of looking at the whole. Greenland ice sheet, you will see graphs like this that say, oh look how much the Greenland ice sheet is melting. They say words like gigatons of ice. Well, we don't measure the Greenland ice sheet in gigatons. We actually measure it in millions of gigatons. That's how big it is. And so if you zoom out and show the total ice, this graph is actually that. See how they can manipulate you with showing the data in different ways. Open water at the North Pole is not new. We've been going up there in US Navy subs. In March of 1959, it surfaced at the North Pole to open water. Did it again in 62, open water. Did it again in 87, open water. Can you imagine if someone took a picture this coming March and it looked like that, the catastrophe it would be in the news? So when the satellites came online in the 70s, we were at a cool period. Some of you remember the 70s was a cool period. We were worried about global cooling, not global warming. And so the satellite record, we have seen that warming and ice going down, but when you start a data set high, it's bound to go down. If we'd started before, we'd had lower levels of ice before, and these pictures show that. CO2, it's plant food. That's really all I gotta say about that with the time I have remaining. Plants need CO2 like you need oxygen. If plants get more CO2, they thrive. Here's some links that show how much they thrive. And we've known this for quite a long time. Here's papers from the 1920s showing how much they were calling it fertilized air, because they were discovering that you could grow food better with higher levels of CO2. So we are putting more CO2 in the atmosphere, and I don't think it's all bad. And here's a graph that shows that. The planet is literally getting greener. CO2 is plant food. Plants like more food. Just like if you put on more oxygen, you're going to perform better. CO2, plants perform better. They get more stomata. They can process water more efficiently. Yes, there are spots where we have deforestation and rainforest, but look along the deserts. Way more plant life. Even out here in the arid west, because if you get more CO2 as a plant, you can grow in a more arid environment. The planet is literally getting greener because you're driving your car. And I want to wrap up with touching on scripture again and then bringing this back to so what? So what? The so what tonight is, why should we care that our taxpayer dollars get the graphs wrong, or temperature, or methane, or what does this matter? Well, this is a graph of life expectancy. And if you notice, what continent do you live the shortest on right now? It's Africa. Folks in Africa, on average, will live about 30 years less than you and I. Why? they don't have access to electricity. Why? Because UN, World Bank, the United States, I found a picture today, I decided not to put it in. They are not allowed to use the natural resources we use to become a first world country. Nigeria, Kenya, places like that, they cannot build a fossil fuel burning power plant or we will pull aid. So they get to live 30 years less because their primary fuel source is dung. Only 25% in homes in Africa have electricity. The demonization of fossil fuels is literally killing about 7 million people per year. Why is it that we got to develop as a nation and become a world superpower on the backs of what? Fossil fuels. And it's being demonized, and they're being told they have to go straight from dung to some expensive green energy, and they can't do it. And they're dying. That to me is a moral issue, and Dr. Roster pointed that out to testimony to Congress in 2019. So I would argue, so where are the grandparents in the room? Do you know, just a generation or two ago, you would not be alive to see your grandchildren because your life expectancy would be 40 or 50 years. I would argue that there's been one invention and one natural resource that God put on this planet for us that makes living to 80 possible. And it was fossil fuels. And as a Christian, we think about the 1040 window, and we think about the gospel going out. How many people groups, languages, tongues has the gospel gone out to in the last 100 years? And how would it have gone without fossil fuels? There would literally probably be hundreds of millions of less Christians on the planet if we didn't use the resources that God gave us. But now, in California, I think here in Colorado, and Fred, you showed that article about Gretchen Whitmer in Michigan. I mean, fossil fuels, state by state, are being outlawed. Then they're making all these electric cars, and then they're going to plug them into what? They already have rolling blackouts in California in the summer because they don't have enough energy. And we just closed down our fossil fuel burning plant down in Colorado Springs. So I think the rolling blackouts are coming our way. Okay? It is a moral issue. Regulating or eliminating cheap forms of energy in developing nations really hurt those folks. And so I urge you to not unwittingly support policies that, one, I don't think are backed by the data, but they really are hurting the poor. Man-made climate change is happening. Anyone ever been to Kitty Hawk? This is what it looked like a little over 100 years ago, and this is what it looks like today. Which one do you prefer? That's caused by man. Essentially bulldozers that piled up sand dunes to keep the water from washing over the islands, and so the ground is not as acidic, it doesn't have as much salt in it, and grass can grow, trees can grow. Those trees were not there 100 years ago, but they're there today. But yet there's signs everywhere when you walk along those boardwalks of, oh, fragile. Well, no kidding. It's fake. We made it. It's not natural. And the birds are endangered, and the turtles are endangered, and none of them were there 100 years ago. So we do have impact, but just because something changes, it doesn't mean it's necessarily bad. So wrapping up, before I field some questions, I am a skeptic that CO2 is what's driving, but I'm not a skeptic that we're warming. We have warmed about 1 degree, and I gave some reasons why, but I do not think this is due to man. I think it's mostly due to natural changes in the environment. Volcanoes, solar cycles, ocean currents, So another way to say that is God big, man small. The climate models I showed you, we didn't have a lot of time to really dig into how those climate models are made. They are not very well, verifying well with observations, but yet those exact models are what's made to make the policy that our politicians are. I do not see or detect major accelerating changes in the hydrologic cycle. I showed you graphs to show us we're really not getting more hurricanes. We're actually probably getting a few less. We're not getting more tornadoes. We're not getting more wildfires in the long term. We've gotten a few more in the last few years than a decade or two ago, but not as much as we had in the 30s and 40s. And so I leave it up to you to draw your own conclusions. That hypothesis from Science Magazine in 2010, is it being supported by the data or not? So what should we do as a Christian? In 1 Thessalonians it says to examine everything carefully. It says to hold fast to which is good and abstain from every form of evil. And what I came to realize is this is not just a debate about which proxy data set to use or how to graph the data. There are people out there deliberately lying to us and withholding the truth, deleting data sets. And a lie is a lie, and any lie is evil. And I see some of the younger folks here tonight. When you're going to school and what you see in the media and there's a fight for your mind. And what they are trying to put into your mind, the first thing they're trying to put in your mind is that there is no God. And I just said this a minute ago. I think actually modern energy exploration has been good for the advancement of mankind. We're not going to be on fossil fuels forever, just like we weren't on whale oil forever. Just like the vast majority of us don't heat our homes anymore by wood. I have a wood stove, but I can do without it. It's not my primary source. The economy, our economic system, when something comes along that outperforms fossil fuels in a reliable, cheap way, fossil fuels will be a thing of the past. But if you go and you examine all the green energies, they're not effective. A quick example: I just was in Southern California. A friend lent me their EV. It works great in Southern California. The battery life was good. I got around, but that same EV won't work in Minnesota in the winter. Battery lasts for about 2 miles. That same EV won't work in Phoenix in the summer. It's too hot. And we're seeing a lot of problems with some of these technologies. I love solar and electric and all these things, but they have their place, but they cannot at this point in time replace fossil fuels. We need a little bit of everything. If you look at the green, there's just failure after failure after failure after failure. We're not quite ready to transition, and we shouldn't be duped or scared into doing it by lies. Genesis 8:21. I'm going to just read verse 22. While the earth remains, seedtime and harvest, cold and heat, summer and winter, day and night shall not cease. God is reminding Noah after the flood, I'm in charge here. Amen. I'm in charge here. It's going to be hot. It's going to be cold. We're going to have warm periods, cold periods, but God's in control. And we shouldn't be fearful that some cataclysmic thing is going to happen. And be honest, the science doesn't back that up. And I have a few more verses right here. And I just like that Colossians 1 verse. Even in our climate, in Christ, in Him, all things, all of creation holds together. So on the paper I gave you a bunch of the resources, various books, various websites. Not all are Christian. They're just ways to get to some of the data. Be happy to discuss more of this. And I think that's the vast majority. I had to move quickly through a couple of things, but what questions might you have tonight that I might be able to field? Oh, don't forget, I put it in there a second time.
Yeah, if you have a question, just let me know. I will bring the mic to you and wait till you get to the mic before you ask your question so everybody can hear it. So let's start with this one here.
When I was in college, the big threat was ozone holes. What happened to that?
I had to move on to the next thing. Not a super expert in ozone. I remember while you were in college, I was in elementary school, so I was that young child with the propaganda in our schools. I think it's roughly the same answers I give tonight. What they're starting to see is that the natural fluctuations in the ozone hole is dwarfed by what man can contribute. It's not that man doesn't affect the ozone and we made some changes, but even though we've gotten rid of all the CFCs, we see dramatic drops and changes in the ozone hole naturally all the time. So it's really hard to say if those, I'm not saying the CFCs had no impact, but it's really hard to say that, when they started measuring the data, all of a sudden they see this big drop, but they can't tell whether that big drop or in the amount of ozone and the ozone hole got bigger, whether that was caused by natural or by man. Again, I think the answer is a lot of natural and a little man.
What caused the Dust Bowl of the 1930s?
Yeah, so 1930s was pre-industrial revolution, not pre-industrial revolution, post-war economic boom. We had a huge economic boom, did a ton of CO2 emissions in the 1940s and 50s, so it was before that. So I'm setting up to say, I don't think it was the burning of fossil fuels. The short answer is, I don't know. Things like the Dust Bowl, things like that Hunga Tonga volcano that causes huge fluctuations in our planet's weather is natural. As I said, it was warm enough to grow grapes in London in around 1000 AD. Now it's too cold. In that little ice age, they used to do ice fairs on the Thames River in London. And now the Thames River almost never freezes over. So the Dust Bowl, I would say, was probably on one of the extremes of how far out our climate can move, and I think it was mostly natural. So probably some combination of El Nino, La Nina cycles, combined with solar cycles, combined with the number of volcanoes that are erupting. We just don't know the exact answer. But we could see it again, I think. But it won't be in the news, it won't be natural. We'll be the cause of it if it happens again. Yes, sir.
Okay. Models are made up of algorithms and combinations of algorithms. And in the last year, I've heard an expert say, in arguing against the climate fear campaigns, that none of the climate models that have been used to project this global warming and global climate change, none of them take into account cloud cover.
So I'm not an expert on the climate models and all of them, because there's literally hundreds of them. I do think they try to take into account cloud cover. I do not think they do so well. Some clouds cause a net cooling of the planet. Other clouds trap in heat. It's a delicate balance. What you're describing in those processes, these models all have knobs that we can tune different parameters, like, oh, well, let's just add some more clouds, or let's add how quickly the energy dissipates, and the bottom line is, so my PhD is in atmospheric modeling. I modeled all the winds that we get down at the Air Force Academy. And in this, I built a model and I tuned it to forecast winds high, because we had some really high events. And I still remember to this day, someone during my PhD defense asking me, did you run your model on a day when there was no wind? And see if your model just always produces high wind. And that's why you're saying it's right for this event. Or run it on a day when it's calm, and does it still produce calm? So if you've already made up your mind that we're going to get warm, and warm this fast, and it's going to be caused by this, you can tune your model to say that. And you can play with things like clouds, and how fast ocean currents move, and how different assumptions of how fast ice melts or doesn't melt. And unfortunately, all the funding from our government is to reinforce this notion that we're going to get warm at alarming rates. So when the government funds scientists to produce models, what do you think they say? Yes, ma'am.
My understanding of the dust bowls was probably man-made, and that was with the settling of the West, and go west, young man, you get free land. You know, all you have to do is, you know, grab it and make your own farm. And they started digging up all of the grasslands and the sod. And when there's no sod and there's just open dirt and the wind starts to blow, they get the dust bowls.
Oh, certainly I think man produced a lot of that dust, but something climatic also happened to shut down precipitation for a while and it be a little warmer for a while. I just don't think it was CO2.
Correct. Yeah.
Whatever it was. Is there a question over here, ma'am?
So one, do you think we're going to run out of fossil fuel?
No. I sat at a lecture at the Air Force Academy in the fall of 1998 in a chemistry class, and the guest speaker came in and he said we would be out of fossil fuel in 20 years. This is the biggest threat to our country and DOD and this and that, and that's now been 26 years ago.
Supposed to be dead.
Yeah, we're supposed to be completely out of oil. Bottom line, technology. We have more known oil reserves on the planet today than ever. We just keep finding more. All the oil sands and shale up in Canada, the types of ways, it's somewhat controversial, but fracking and other ways. We just keep developing new techniques to get at them. And that's why it's so cheap. I know we complain about high gas prices, but if gas would have followed inflation since the beginning of the 80s, we actually should be paying more like $10 to $15 a gallon. You all see the other commodities that cost a lot more, and frankly, the price of gas isn't. I mean, it goes up, it goes down, but we're still roughly been in the same range for the last 20 years.
And then what about using solar and wind? Do you think those are going to come up more, or do you think they're just like a foo-foo thing to do?
No, they make total sense.
Or whatever.
Yeah, they make total sense in some places. So I mentioned, the battery in the EV is not going to work very well in Phoenix, but you can sure collect a lot of sun in Phoenix, Arizona. But that doesn't work in upstate New York when you're getting snow blowing off of in Buffalo, New York. Each one makes sense in certain places, but it doesn't in other. Germany went really, really heavy into wind, and then they didn't get any wind for like 8 days, and all their factories had to start shutting down because there was no power. So we need to design our networks in a way where we can utilize some of those things, but when those things stop working for whatever reason, all the windmills froze up in that big cold freeze down in Texas, what do we need to be able to fire up to turn back on so we have electricity? So kind of the plug and play, or the thing that you can easily you can control how much you do, is those fossil fuel burning power plants. So without them, we're going to see more and more less reliable grids. I think we're seeing blackouts coming here to Colorado if we keep shutting them off. They already have them in California. Yes, ma'am.
So over the last couple years, we've been seeing a lot more in the news about weather manipulation.
Yes.
Thoughts on that? On it? Will it touch the data at all, or again, will it be something so small, or is it being done to support the data?
Yeah, I used to teach a class on cloud physics at the Air Force Academy, and one of our lessons in there was on cloud weather manipulation. Just a couple pieces of history. We do it. anyone remember the Olympics out in Beijing, Summer Olympics many years ago? They actually did cloud seeding, the Chinese did. There was a storm front coming in, and they cloud seeded the heck out of that storm, so they all rained out and didn't interrupt their opening ceremony. So it changes things, but not in the net, not in the hole. So it rained over here instead of here. It didn't rain everywhere. There's some cloud seeding. I had a friend who worked on a project up in the Dakotas, and they were trying to make more rain in the Dakotas. Well, they got more rain in the Dakotas, and Minnesota got less. Vail Resorts does cloud seeding. We here in Colorado, California, same thing. When the storms come through, we try to get as much moisture out of them as possible to increase the snowpack, do the reservoirs. Interesting one, military background, Google Operation Popeye. It was a military operation during Vietnam trying to flood the Ho Chi Minh Trail using cloud seeding. So bottom line is we do it. I don't think it's ultimately super destructive on a global scale. It just might mean the farmers in North Dakota get a little more water than those in Minnesota, and they probably need to work that out. Yeah, we're cloud seeding here in Colorado, so we're probably still in some of that moisture from Kansas and Oklahoma and other places, and putting it in the snowpack here in the Rockies. Then we'll sell it to them as we send the water out.
So we got time for one, maybe two more questions. So I saw another question here. Does anybody have any other
Is there any
questions that are
online
pressing?
tonight?
No questions online.
No questions online. All right.
I've heard, I even read a book about solar radiation was supposed to affect things, and this guy was saying we're entering another little ice age kind of a thing. That didn't seem to be the case. You had a graph up there that seemed to indicate solar radiation fluctuated. And it sounds, do I understand, the summary I'm going to take away, do I understand you're saying it's more effects on varying rates of, I'm forgetting the word, leaving the Earth, and caused by natural events that are really unpredictable?
So, I want to make sure I'm understanding your question. Something to do with the solar cycles.
Yeah, the solar cycles, the incoming radiation varies some, but it's
Yes.
really not the driving force, it's more the change in the outgoing radiation.
Well, on that graph that I put up, that was the same scale between the incoming and the outgoing, watts per meter squared. And you can see, yes, the solar fluctuation is smaller in magnitude and the others are larger. So I do think the sun is what drives it all. Small changes in the sun can then change weather patterns, and then those weather patterns may lay down a lot more snow, which then start all those other natural processes. So that while you may not directly attribute the large fluctuations directly to the sun, indirectly, the small changes in the sun can be magnified. The Earth's climate is a nonlinear dynamic system, and if you know anything about nonlinear dynamic systems, anyone ever heard of like chaos theory or the butterfly effect, right? You know, a butterfly flaps its wings in sub-Saharan Africa, and 2 weeks later a Category 5 storm hits New Orleans. You know, these small little changes, even in the sun, can be magnified through the complicated natural processes in the planet that, quite frankly, we just don't understand. But the science is settled. Maybe one more?
Yeah.
And then if you don't get your question answered, I'm happy to sit around and answer your question one-on-one.
The question is, what do you believe is behind
the abuse of science here. With the prevalence of evolution generally perceived as a fact in all of our educational institutions, cosmological evolution considered a fact, Big Bang Theory considered a fact, is this necessary to remove God further when he's already been, or is this more of a political, economic, what's driving the abuse of science, in your opinion? I'm not sure we'll ever know.
Well, so now you're asking me to go outside of my field, and that's fine. I don't work for DOD anymore. I was far less comfortable when I used to stand up here as an Air Force officer. You know, if you look at the vast majority of those that are behind in funding this movement, those who want power want control. And if you want control on a global scale, you have to contrive a global threat, and it has to be something that controls you economically, something that controls your you politically, right, in order to drive to all of these things. And so I mean, I don't think it's an accident that the vast majority of the advocates of the Green New Deal and this and that are also socialists. And so they know our Bible, though. See, doesn't God tell you to be a good steward of the earth? So let me tell you how you need to be a good Christian and be a good steward of the earth, right? Remember, you know, religion's the opiate of the people, and they understand that, and they use our own Bible against us, and that's why I want to inform you with facts that you driving your car is not you being a bad steward of the earth. They just want control of you and your pocketbook and your vote. By the way, Biden didn't go to the climate conference in Dubai this week. It's not politically expedient.
All right, well, I guess that concludes the proceedings here. So let's give Dr. Homan a round of applause. And I just want to mention that he drove his four-wheel drive vehicle up here from Colorado Springs, so he will be willing to stick around for a while and answer questions one-on-one. He's got a pretty cool table set up in the back for Officers Christian Fellowship if you're interested in what they're doing. I'd encourage you to go down there and out there and peruse that table as well. I have a few hopefully quick announcements here. Let's see. Okay, so the first one is that I just wanted to do a reminder that Rocky Mountain Creation Fellowship exists only on your good charity. Everybody that does stuff for Rocky Mountain Creation Fellowship, we do it on our own time as volunteers, so every penny of anything that you might be willing to donate to us goes to the work of getting the gospel out from the creation. And if you are inclined to give a gift year end, this is a good time to do that. You can mail a gift into our P.O. box, or you can send it, or you can use a QR code that's in our Foundations magazine. Let me just pull one here. This is a copy of the Autumn Foundations. Unfortunately, we've only got 2 left, and this is one of them. But you can find the QR code there in the first page if you want to give a gift through that, or you can find our mailing address on the opposing page. So there's the QR code and mailing address is there. Or you can go through the website at www.youngearth.org. And so anyway, just wanted to put in that shameless plug. So, as far as the future goes here, January 12th, we are going to have Jerry Simmons again. I believe it was last January he was here. Goes by Doc Rock. He brings in all kinds of rock samples. He was, this last summer, he did some more dinosaur digs up in Hell Creek Formation. So he should have some really interesting new finds to talk about in regard to that. On February 9th, we will have Bill Jack from Worldview Academy. I don't know exactly what he's going to be speaking on, but it's always a pleasant surprise. I am going to ask him to speak on something that will appeal to young adults. So if you are a young adult, this should be a great meeting for you to come to. We're still in the process of arranging creation tours of the Denver Museum of Nature and Science. So keep your eyes open, especially on the website. As soon as we have some date or something, we will announce it on that. Of course, we always need volunteers and helpers to help out with the things that we do. So if you're interested in volunteering, please come and see me, and we can talk about what might happen. Beyond that, we have food and drink out there in the cafeteria, which is way across on the other side of the foyer. So if you're, I guess it's time for me to stop talking because this mic is cutting out again. So if you're interested in hanging out with and having some fellowship and food and stuff, you can go over there. And I just wanted to give you a note. It looks to me like it just recently started snowing, a very fine snow. So you'll have to clean your car off when you go out there, but my guess is that the roads won't be too bad yet. So with that, bid you a very Merry Christmas, and thank you all for coming, and we will officially adjourn at this point.